Today we will be going over our last lesson in the moles unit. We're going to determine molecular formula from empirical formula. So if I haven't discussed this in class yet, the molecular formula is basically the unreduced formula of a molecule, and the empirical formula is just the reduced formula. So for example, if the molecular, I can't speak and spell molecular. If the molecular formula is C12H24, okay, let's say that's the molecular formula. Please don't quote me on this. This probably doesn't even exist. But let's say this is the formula, and the empirical formula, the empirical formula will be CH2. Okay, so it's just basically the molecular formula but reduced. So we're going to today calculate or determine the molecular formula when we are given an empirical formula. So much of what we're doing today will be what we did yesterday, just there's one more step on top of what we've already learned. So, I already told you, we're going to calculate empirical formula given the percent makeup of the molecule. To determine it, I'm just going to go through them. First, you need to determine an empirical formula, which is what we did yesterday. The two steps after is new for us. So we're going to use the formula molar mass of molecular formula over molar mass of empirical formula. So, and then we will multiply by the subscripts in the empirical formula to get the molecular formula. So again, that's all just words. Let's actually get to a problem, and it might make more sense to you. So the question is, what is the molecular formula for a compound that is 74% carbon, 8.7% hydrogen, 17.3% nitrogen, and has a molar mass of this amount? So that's where we get our, if you look in the other one, the molar mass, that's that top number. And then we're going to get the empirical formula. We're going to get the empirical formula and then calculate its molar mass, and then we'll just divide. So simple. Okay, so we're going to first determine its empirical formula. So it is 74.0% carbon, 8.70%. I actually want to give myself more room, I'm sorry. You guys know what these equations look like, and it would be rather annoying to not have a little bit more room. Okay. So 8.70% hydrogen, and then we're going to do 17.3% nitrogen, and then we're going to do, that's it, it's just those three, and we have a altogether molar mass of 243.39 grams. So this would be the, what's it called, the molecular, the mass of the molecular formula. All right, so we know what to do with this. We're going to first convert to grams. I almost converted to moles, but it's, almost the same. So 74.0 grams of carbon. This one's 8.70 grams of hydrogen, and this one's 17.3 grams of nitrogen. And we are just going to do our conversions, like that. And we know that whatever's up here must go here. Grams of carbon, grams of hydrogen, grams of nitrogen. And then up here it will be 1 mole of carbon, 1 mole of hydrogen, 1 mole of nitrogen, and we will have converted to moles. All right, so for every 1 mole of carbon, where is my periodic table? Here. For every 1 mole of carbon, we have 12.011 grams. Okay, For every 1 mole of hydrogen, we have 1.008, you can't see it. Sorry, 1.008 grams of hydrogen. For every 1 mole of nitrogen, we have 14.007 grams. Okay, now we just put it in our calculator and we will have converted to moles. And then remember, we divide by the lowest mole number. Turn it on. Okay, so it's 74.0 divided by 12.011. So we have 3 significant figures, so 6.16. Okay, we have hydrogen, so 8.70, that's a 7, divided by I'm getting a little tired, I guess. 1.008. Okay, we have 3 significant figures, so 8.63. Okay, and last one. Three significant figures, 1.24 moles. So none of this is new so far, so we need to actually divide each of these numbers by the smallest of each. So the smallest of them all is 1.24. So we're going to take 6.16 divided by 1.24, 8.63 divided by 1.24, 1.24 divided by 1.24. So there should always be at least 1. Okay. Let's do our calculations. We have 3 suffix, so 4.97. I'm okay with this being 5. 8.63 divided by 1.24. And I am also okay with that being 7. Okay, so now we will just write our formula. I guess right here we have some room left. We'll write our formula. This is 571. So we have C H N 571. We don't have to write the 1. Okay, so now we just need to calculate how much it weighs. And let's scoot it over a little bit to make it, there we go. That's better. Okay, so we need to calculate how much it weighs for the empirical mass, because we have the molecular mass here, okay? And we're going to divide that by its empirical mass, which is what we're going to calculate. So we have carbon, we have hydrogen, and we have nitrogen. We have 5 carbons, we have 7 hydrogens, and we have 1 nitrogen. So we're just going to multiply by how much it weighs, and then add them together, and that will be our answer. So carbon, there's 5 of them, and each carbon will weigh 12.011. Okay, hydrogen weighs 1.008. If you don't believe me, look back, look here. If you don't believe me, look on a periodic table. Nitrogen weighs 14.007, and we only have 1. So I'm just going to go ahead and do it in my calculator because I've run out of room. All right. So I'm going to use parentheses. 5 times 12.011 plus parentheses 7 times 1.008 close parentheses, plus, we don't really have to multiply it by 1, so 14.007, and that equals 81.118. Significant figure-wise, let's do 3 digits past the decimal. Let's just keep it all, I guess, 81.118, okay? So over here, we're going to add 81.118, and again, you're going to see that it's a little different on the PowerPoint. That's okay. It depends on the periodic table you're using. If this is the only video you're watching and you didn't watch the previous ones, just make sure you use the periodic table that I give you on the test and you'll be just fine. So you take that and you find out what number it is. So it's 243.39 divided by 81.118. And that basically equals 3, okay? 3. So what we do with this number is we're determining the molecular formula. So what we do with this number is we've got C5H7N. We're going to multiply every single one of those by 3. So 3 times C5H7N, okay? And so then the molecular formula will be 3 times 5 is 15, so C15. 3 times 7 is 21, and 3 times 1 is 3. So this would be the molecular formula. So basically, you do the exact same thing all the way up until here. You've got your empirical formula. You find out how much the whole empirical formula weighs, divide it by the number they give you for the molecular formula, find out what that whole number is, multiply it by the empirical formula, and boom, you've got your molecular formula.